Hello, this is part A of the Chapter 7 lesson. In Chapter 7, we're going to introduce an idea called hypothesis testing. And in part A, we're going to talk about one specific type of hypothesis test that we use to test a claim about a single population mean. A note about these lessons is that for all of these lessons in Chapter 7, we're going to use the Excel workbook titled Chapter 7. And we're going to do all of our calculations in that workbook. I want to start off with a review of a slide that we've seen at least twice before, and this relates our two general types of statistical concepts. Two types are descriptive statistics and then inferential statistics. Remember, the big goal of statistics is that we want to know something about a large population. But in order to know that exactly, I'd have to go out and get information from every single member of my population. That's very difficult, if not impossible, to do. So instead, we're going to go out and get information from a small sample of the population, calculate descriptive statistics like the sample mean, sample standard deviation, sample size, and then use that information to draw conclusions about our population. Now, in Chapter 6, we talked about doing this with the use of confidence intervals, where we use confidence intervals to calculate like a confidence interval estimate of a population mean or a population proportion. And we used we used probability to make that connection between the population and the sample. In this chapter, we're going to talk about a different way of making that connection, again with probability, but we're not going to be calculating confidence intervals. We're going to be testing a claim about this population using sample statistics. Okay? So to illustrate this idea, let's look at this first example. A researcher claims that the mean weight of all men in the United States has increased from the year 2002 to the year 2006. Now, in the year 2002, the mean weight of all men in the United States was about 191 pounds. Now, exactly how we know that, we won't worry about. We'll just take this information for granted. Okay? Now, to determine if this claim is true with 100% confidence or certainty, we would have to weigh every single man in the United States in the year 2006 and calculate the population mean mu by adding up all of those weights and then dividing by the total number of men in the United States. Now, that's impossible to do. It's impossible for a couple of reasons. Number one, this 2006 was several years ago, so we can't go back in time and weigh every man. But even if we were talking about the current weight of all men, we still couldn't go out and weigh every single man. There's 150 million men in the United States or so. We can't weigh every single one of those men, and so that's just impossible to do. So we're never going to know with 100% certainty if our claim is true or false. So instead, we're going to have to go out and get some sample information or information from a sample of men, and then use that information to try to determine with some level of certainty if our claim is true or false. And so suppose we did that. Suppose we went out and we weighed a sample of 100 men and calculated a mean weight of 197.1. So in other words, we went out, we weighed 100 men, we added up those 100 weights, divided by 100, and we got a sample mean of 197.1. And then we calculated a standard deviation of 25.6. Now, the standard deviation would be calculated in the same way that we introduced it back in Chapter 4. Okay. Now, we might be tempted to stop right there and say, well, wait a minute, this data proves my claim, because 197 is much greater than 191. But this information, or this data, does not prove our claim is true. This number 197.1 is a sample mean, and as we illustrated in the last chapter, a sample mean is an estimate of the population mean. This tells us that our population mean is probably somewhere around 197 pounds. So our data appear to support the claim, but we want to ask ourselves just how strong is this support? Is this just kind of real weak support, or is it real strong support? In other words, is it enough support to say that my claim is probably true, or is it just kind of some weak evidence that we can not take terribly seriously? Well, we're going to try to answer this with this idea of hypothesis testing. Hypothesis testing is a formal approach to determine if data from a sample support a claim about a population. So we start off with a claim about a large population. And again, to determine if that claim were true with 100% confidence, we'd have to go out and get information from every single member of my population. That's impossible to do. So instead, we're going to get data from a sample and determine, does that data really support my claim or not? Now we're going to talk about 8 or 9 different hypothesis tests here in this chapter, and then we're going to talk about a few more in chapter 10. But all calculations are done differently, but they all follow the same basic 4 steps. And these 4 steps are, number 1, state what we call the hypotheses. And there's going to be 2 of them, what we call the null and the alternative hypothesis. And then we're going to calculate something that we call a test statistic. And this is calculated using some probability. And then based off of that test statistic, we're going to get a p-value. P stands for probability, and so this p-value is going to be a probability. And then based off of that probability, we're going to state a final conclusion, which kind of summarizes the results of my hypothesis test. So these are the same 4 steps that we're going to go through for all of our different hypothesis tests that we talk about. Okay. So really the first step, even before we set up the hypotheses, is to define the parameter. Now, when we define the parameter, we define what it is we're making a claim about. We're not simply restating the claim, we're defining what it is we're making a claim about. Now, this step is very similar to defining the parameter that we did back in chapter 6, so there's really not a whole lot new. But in this particular example, the claim is that the mean weight of all men in the United States has increased from the year 2002 to 2006. So in other words, we're making a claim about the mean weight of all men in the year 2006. So that's our parameter. We're going to denote it mu. Remember, mu always denotes a population mean. And so that's our parameter. Okay. Next, we're going to set up our hypotheses. And there's 2 of them. The first one is called the null hypothesis, and it's denoted with this symbol h sub 0. The null hypothesis is a statement that the parameter that we just defined equals some value. And we could think of this null hypothesis as a statement of the status quo, or it's a statement of what we might expect to be true in the absence of any data. Or stated another way, we could think of the null hypothesis as a statement of no change. In this particular example, we're claiming that there is a change, but the null hypothesis is a statement of no change. Okay. So here's our example. Here's the claim. The mean weight has increased from the year 2002 to 2006. 2002, the mean weight was 191 pounds. So our parameter is mu, the mean weight of all men in 2006. So if there were no change, then mu would be equal to 191, the mean weight in the year 2002. So our null hypothesis is going to be the statement of no change. Null hypothesis is the statement that mu equals 191. Now, our second type of hypothesis is what we call the alternative hypothesis, denoted with the symbol H1. We could think of this as a statement of the investigator's belief. The alternative hypothesis is also called the research hypothesis. Okay. So again, going back to our example, here's our claim that the mean weight has increased. In 2002, the mean was 191. Our parameter is mu. And so the investigator's belief is that mu is bigger than the mean weight in 2006, which was 191. And so the investigator's belief is that mu is bigger than 191. And so our alternative hypothesis is going to be the statement that mu is greater than 191. So as we see in these examples, that in this example, that the null hypothesis is always going to be the statement that our parameter equals some number. Our alternative hypothesis can take one of three different forms. One form is going to be the statement that the parameter is less than some number. Here mu naught denotes some number, and mu is our population mean that we're making a claim about. If we have a statement of this form, we're going to call the hypothesis test a left-tailed or a lower-tailed test. Another type of statement could be the alternative hypothesis that mu is greater than some number. This is what we generically call a right-tailed or an upper-tailed test. The third type of statement is going to be the statement that mu is not equal to some number. And in this case, we call it a two-tailed test. And then the left and right-tailed tests are generically called one-tailed test. So whether we have a one-tailed test or a two-tailed test is going to be very important to how we do our calculation.